This is an example of how a typical day covering a new topic might be covered in one of my math classes. Now, I've coded these problems in a thing called My Open Math. It's free for students to use. In fact, my kids, I've set up courses for my kids. But this is like a dynamic whiteboard and student notebook. So the instructions of this particular problem want the students to solve this system of equations. Equation 1 is in red, equation 2 is in green. Instruction 1 is to graph the red equation using its intercepts. And so the x-intercept is the value of x when the height of the line is 0, when y equals 0. So what I'm going to do, what I tell students to do is just type the red equation, 4y plus 8x equal to 256. Now, when I hit enter, it marks it wrong. And the reason why I do this is because I want students to literally replace y with parentheses and then type a 0 inside the parentheses. So what My Open Math is going to do, it's going to take 4 times 0, and it's going to add that to 8x, and that's going to equal 256. And you hit enter, and now it marks it green. So students get instant feedback. Then what I'm going to do is I'm going to simplify this as I would on a whiteboard. So if I'm doing it on my virtual whiteboard, my interactive virtual whiteboard. And this encourages students to engage in the classroom, and I can ask them, all right, what's the next step? And one might say 8x equals 256. We hit enter to check our work. And the cool thing about this, as you work out the problem, students can open this back up after we've worked it out, and they can check these buttons here to see what My Open Math is doing. So the next step here would be to divide 8 on both sides of the equation. Now, if you want to divide a number only by itself, you can highlight the number and then hit divide, the slash, and then 8. And you do the same thing on the left side. So if you did to one side, you did to both sides. And we hit enter to make sure that we did it right. And it marks it again correct. Now I might ask another student, all right, what's the next step? And one might say, well, you have to simplify that further, right? 8 divided by 8. 8 divided by 8 is 1, and 1 times x is x, right? Okay, then we can have a calculator. Let me open up my calculator here. We can use the students' Google Chrome calculator. I'll put it right here. So 256. I can have students do this for me. Divided by 8. And it equals 32. So the x-intercept is 32. Okay. Now we want to find the y-intercept of that same equation 1, the red equation. So again, I'm gonna go ahead and copy this. And I'm going to reset it to what it was originally, right? 4y plus 8x equals 256. Now, if I hit enter, as I will do in class, I'll go, why? I'll ask the student, why is that incorrect? And then the student will go, well, the y-intercept is found by replacing x with 0. So I'm going to take out the x, put in a parenthesis, and then enter 0 inside the parentheses. And I hit enter, it marks it as correct. And then I'm going to copy that. And then I'll ask another student, all right, what's the next step? The next step is simplifying. 8 times 0 is 0, and 0 plus 4y is just 4y. And I'll ask the next student, what's the next step? Right, so everybody's engaged. Everybody's getting green check marks. The next student will say, well, we got to divide both sides of the equation by 4. Again, to do that, you highlight the 4, hit the slash, and then type 4. Highlight the 256. If you do it to one side, you got to do it to both sides. I don't like the word canceling. Hit enter, and we get those two marked correct. And then the final step is to recognize that 4 divided by 4 is 1. People say 4 cancels 4, but I like to say 4 divided by 4 is 1. And 1 times y is y. And then I pull up my calculator, or I have a student pull up their calculator. We take 256 divided by 4, which is 64. Now I have both intercepts. I can graph the equation 1, the red equation. The x-intercept is 32, the y-intercept is 64. So I'm going to go down to my graph here. And this is really cool because MyOpenMath will allow you to set this so that you have to be exactly right. So the y-intercept was 64, and the x-intercept was 32. Now, if we forget, because I tend to talk a lot, if we forget, we can go back up and double check. So the y-intercept is 64, the x-intercept is 32. And I've set it so you have to be exact. And you notice that you can move it after you've done it. So you can start here at 60, and you can go up 1, 2, 3, and 4. And then double check this one. 0, 1, 2. Yeah, there we go. All right. So I think the equation's set pretty good. Now we're going to do the same thing to equation 2. And equation 2 is just x equal 10. Now, x equal 10 is an equation in one variable, right? So the x-intercept is 10. Now, because the next time we do this particular problem, the equation 2 it might be something like 3y plus 4x equal 50, right? On this particular iteration of this problem, equation 2 has just one variable, one unknown. So in this situation, you would just type x equal 10 all the way down, right? I got cap lock on. So this particular one's pretty easy, right? I got different versions of this problem where we have two parallel lines, intersecting lines, perpendicular lines, lines on top of lines, and then I got lines that go down and lines that are vertical versus lines that slope up or are flat. I got a bunch of different combinations of this particular problem. I'm just showing you one type for time. So the x-intercept is 10. Now down here, the y-intercept, no matter what y is, x is always 10. So y could be minus a billion, x is going to be 10. Y could be 0, x is 10. Y could be 50, x is 10. So the y-intercept here is infinity. And the way I do infinity in MyOpenMath is I just type y equal to 00. The 00 is the infinity symbol that I use in MyOpenMath. I'm going to copy this all the way down. Then I'm just going to type 00 here. 00 is it's a sideways 8. It's my infinity sign. And we get all those correct, right? So when you have when your y-intercept is infinity and your x-intercept is 10, it's a vertical line. So what I'm going to do is I'm going to put a dot here at 10, and I'm going to go up. I could go anywhere. I could put it here. I could put it there. I got a vertical line. Now I'm going to check my work. So to check my work, I'm going to add a decimal place here that I'll end up deleting, and I'll see if my equation. Now I didn't get the graph corrected yet. It's still like partial credit because it's orange, and when the graph is perfect, it'll be green outlined, right? So what that means is there's a graphing assignment below. Okay. Now down here, I want to solve Equation 1, 4y, because the y is on the vertical axis, right? The y-axis is the vertical axis. So I'm going to solve it for y here. So what I'm going to do is I'm going to rewrite it. I can write it as 4y plus 8x equal 256. But these are identical. So what I'm going to do is I'm going to ask the student, what's the first step? And the student will say, we got to subtract 8x from both sides. So when we subtract 8x from both sides, positive 8x minus 8x, well, that's 0. And 4y plus 0 is 4y. If I did it to one side, I got to do both sides. So I just moved the 8x over to the right side by subtracting it from the left side and the right side. I hit enter to make sure I did it right. And everybody gets a green check mark. And then, what's the next step? I'll ask John. John, what's the next step? And John will say, well, we don't want to know what 4y is. We want to know what y is equal to. And then I'll go, all right, how do we do that? And John will say, we got to divide both sides by 4. So I'm going to divide well, what I'll do is this. Instead of doing it that way, I'll do it this way. I'll divide this side by 4, and then I'll divide this side by 4. And I'll hit enter to make sure that I got it right. So this gives you a kind of a step-by-step process through solving for y. And then I'm going to copy this because it's the easiest way to do it. And then I'll ask another student, all right, what's the next step? That student might say, well, let's use the commutative property and move y down there. So we got 4 divided by 4 times y. And then we're going to do the same thing over here, but for addition. So I'm going to get rid of the minus 8x up here. Then I'll get rid of the plus 256 there. All right, so then we can simplify, right? The next step is to simplify even further. And we can write it like that because 4 divided by 4 times y is just y. 4 divided by 4 is 1. And 1 times y is y. And then we know we can pull the x down. Instead of doing minus 8 times x divided by 4, we can do minus 8 divided by 4 times x. Whoops. Oops. I used the wrong. There we go. And then this value here, this is an opportunity to ask students, what is this? Well, this is the slope, and this is the intercept. And we've already calculated the intercept, right? The intercept was 256 divided by 4. 256 divided by 4 was 64. So we can just replace that with 64 there. And then minus 8 divided by 4, well, that's just that's a fancy way of saying minus 2. And we can enter to make sure we did it right. And we did, right? Now, here in equation 2, normally I would ask students to solve equation 2 for y, but again, it's an equation in one variable x. So since x is just equal to 10, it's in terms of x already, it cannot be solved for y. And so all we have to do at this point is substitute it in the equation above. And that gives what? So I'm going to copy the equation from part 4. And I'm going to put it right here. And then I'm going to replace x, this is the substitution method, with parentheses. Whoops. So I've replaced x with parentheses, and inside those parentheses will be the value 10, because x is equal to 10 in equation 2, right? And we can hit enter, and we can see we get that right. Now it's just a matter of doing arithmetic. So minus 2 times 10 is minus 20. Minus 20 added to 64 is 44. Okay. Then we come up here and verify in the graph. Now, when x is equal to 10, y is equal to 44. So we just visually verified that our solution works. Okay. Now, I like to include a real world application with the algebra. I think it makes it more fun to learn. And so in this real world example, we're going to suppose y is the price of electric vehicles, which are very popular things now. But why, electric vehicles don't cost $44. They cost $44,000, right? So y is in thousands of dollars, right? So this would be interpreted as $44,000. X is millions. I mean, Elon Musk is not selling 10 EVs. He's selling 10 million electric vehicles, right? And he's producing them, right? EV, and we're gonna assume in this model that EV buyers buy just one EV a year, right? If a person wants to buy two, they'll wait maybe a second year to buy their second EV, right? So this is just kind of a simplifying assumption. The downward sloping line represents the demand curve. So when the price is high, not very many is sold. When the price is zero, everybody wants to buy one, right? So that's the law of demand. When the price is high, quantity sold is low. When price is low, quantity demand is high, right? Okay, so continue with this real world example. The value of y at the point where supply intersects demand is called the market price. So the market price looks like it's $44,000, right? Because that's what y is when x is 10. In this case, quantity would be 10 million EVs sold, right? And the market price would be $44,000. So with this interpretation of the model, we just type in $44,000, the answer we got here. And we press enter to make sure we did it right. Now, use the downward sloping line to find the maximum price. The first EV buyer. Now, all this is just kind of like graphical stuff. We're kind of like done doing math, right? So now we're kind of interpreting model with these assumptions. So the downward sloping line, we're going to use the downward sloping line to find the maximum price the first EV buyer is willing to pay. Now, the first EV buyer, you can think of that person as the person who's willing to pay the most. Rich people are able and willing to pay a lot of money for electric vehicles. Poor people aren't able to buy an electric vehicle. They can only buy it at a really, really low price. A poor person on unemployment benefits isn't going to be able to buy an electric vehicle for $44,000. They're just not going to be able to do it because they don't have the income, right? So we can think of the demand curve as a queue of people from the person that has the highest willingness to pay to the person that has the lowest willingness to pay. And the person that has the highest willingness to pay is the first EV buyer. You can think of the most desperate to buy an iPhone is the guy standing in line, waiting a week, camping out in front of the Apple store near Central Park. They're camped out for a week. In the TV show How I Met Your Mother, Lily and Robin camped out overnight, and they were like 10th in line, right? There was somebody at the front of the line camping out longer. That person is willing to pay the most. Time is money. So this very first person, now here's a hint that I provide to students that I'll let them figure this part out right here, right? With X in millions of EVs sold, the value X for this first person in line is approximately equal to 0, since it would be equal to 1 divided by a million, right? Because remember, X is in terms of a million, right? So all we have to do is plug 0 into our model. When we plug 0 in our model, we find that when we're talking about the very first consumer in line to buy an electric vehicle, the one that's willing to pay the highest price, well, they're willing to pay the Y-intercept, $64,000. Right? And again, I had the students figure this part out. Now, the first person to buy an EV probably has what? I'll pose this to a student. All right, which one of these is the best answer, do you think? I mean, who's willing to pay the most for a burrito if only one is sold? Well, you know, LeBron James, he's got lots of money. Maybe he likes burritos, right? He doesn't go buy the burrito from Taco Bell. He hires somebody to go get it for him. So he's willing to pay a lot of money for that burrito. I can't afford to pay somebody to get a burrito for me, right? So we're talking about somebody with a very high income, right? Now, while the 10 millionth buyer, right? The 10 millionth buyer, right? The 10 millionth buyer, again, this is in millions. So this 10 millionth buyer can pay $44,000, right? Now, who is that? Well, of the choices, you know, we're not talking about somebody with low income, right? We're not talking about somebody with very high income. We're not talking about somebody with high income. We're probably talking about somebody with median income, right? And likely is, I don't think that median income, you know, if you're a single mother and you're making a medium income, $44,000 is a lot of money for you. If you're a farmer, having an electric vehicle is probably not very economical given that you need pickup trucks. So the best answer would be like a government or a high-tech worker. Right, and then we hit enter to see if we get these answers correct. Okay, so we're understanding who populates the demand curve here. Now, who, really high income earners, and median income earners who probably live in a city, work for government, or work for a tech firm, right? Well, who are the people that don't buy the car? Well, they're farmers, people live in rural states, people who have big families, people who drive a lot. Out west, you know, out in some states, there's not a lot of charging stations yet. And people making under median income probably can't afford a $44,000 brand new car, right? So I think it's really important to understand who's behind these demand curves. Now, here's an interesting question. The EV maker's revenue, and again, revenue is price times quantity, equals what at this point? Well, the price is 44,000. The price is 44,000. That's the market price, right? Price is 44,000, and 10 million were sold. So this is a great time to talk to students about units. This is in terms of thousands, and this is in terms of millions. So 1,000 million is $1 billion, right? When you multiply $1,000 times 1 million units, you get billions of dollars. So all the students have to do is multiply the 44 times the 10, and you get $440 billion. Okay. Now, with EV production being relatively new and very costly, given how new it is, we're going to assume the cost of making EVs equal the revenue that is generated in EV sales. So that means the billionaire EV maker profit, right, is zero because they just started out, right? They haven't streamlined their production yet. So the profit is zero, right? Now, because government recognizes this, government wants to prevent the EV maker from going out of business, right? Because they want people to switch to electric vehicles, and they're hoping that over time, the electric vehicle company will succeed, and people will be able to buy electric vehicles. And as more car companies buy electric vehicles, maybe the electric vehicle price comes down because of competition. So the government is considering a subsidy that would give electric vehicle buyers $10,000 each at the moment they purchase an EV. They don't get the $10,000 and then they can't lie, right? In order to get that $10,000, you have to go into the dealership, sign the paperwork, and then drive away with a car. That's the only way you get this subsidy. It is tagged to this purchase. Now, if enacted, the program would increase the demand of EVs to this new version of equation 1. Notice the slope is the same, minus 2x, right? When we solved it, we had minus 2x. The intercept, remember, the value on the vertical axis, the y-intercept, is in terms of thousands of dollars. So all we did is we add 10 to the 64 to get a new intercept of 74. Now I want to plot this new demand curve in the graph above and then use it to determine the new market price. So the new intercept is 74. I think it's 74 right there, right? If we get it marked wrong, we can always fix it later. Those look like parallel lines, right? And then I'll go ahead and hit enter. And now notice we have a green box around our graph. So our graph is 100%. So we did the graph correctly, right? Now, again, this is just a matter of reading the graph. We're going to plot the new graph, plot the new demand curve in the graph above, and use it to determine the new market price. Remember, market price is where the supply, 10 million cars, meets the new demand curve. And it looks like, if this is 44 and the subsidy was 10, well, this has got to be 54, right? If we use a little common sense there. We can also plug 10 into here, right? 10 times minus 2 is minus 20. And adding that to 74 gives you 54. So the new price is $54,000, right? Now this is where economics gets really fun. Okay, if the subsidy is enacted, the EV market's revenue increases to what? Well, it was 44 billion, but is now 540 billion. Remember, when we multiply thousands of dollars by millions of cars sold, we get billion. 1,000 million is a billion. So all I got to do is take the 54 and times it by the EV maker's capacity of $10 million produced a year. We get $540 billion. Now, since the size of the factory is fixed in the short run, right? There's only so much production. The EV maker's production is capped at 10 million per year because that's, Rome wasn't built in a day, right? So you have this factory, its capacity is fixed. All it can handle is 10 million EVs per year, right? With that holding his cost constant, because he made 10 million before the subsidy and he's making 10 million after the subsidy, we're assuming we're holding everything else constant. So the costs haven't changed. The subsidy would increase profits by the difference of 540 and 440 billion dollars, or 100 billion. Dollars. So the billionaire's profits went from 0 to 100 billion. So this is an interesting consequence of subsidy. The direct financial benefits of the EV buyer subsidy program accrue to whom? I gotta this up here. Let's see. See it. Okay, what, and I pose this to the students. Who is benefiting from the subsidy? The subsidy is given to the purchaser, but what happened? Before the subsidy, they paid $44,000. After they get the subsidy, the price is simply raised to $54,000 per vehicle, right? So whether we're at this point after the subsidy is in place, or we're at this point before the subsidy is in place, out of pocket, the buyer pays $44,000. The buyer pays $54,000 here, but $10,000 of the subsidy, $10,000 of that is a subsidy that accrues to the EV billionaire. So in this situation, the entirety of the direct financial benefits of the EV buyer subsidy program accrue entirely, not to the EV buyers, entirely to the billionaire EV maker. So the billionaire EV maker was on the cusp of maybe bankruptcy. If the economy goes into recession, all of a sudden people aren't going to buy electric vehicles. He might go out of, he can't pay his loans and he goes out of business. But with the subsidy, it keeps him in business, and all the benefits, all the direct financial benefits of the program go to the billionaire. They don't accrue to the buyer. And that's my demonstration. Thank you.